So first thing, before we implement, we learned that there's several ways to implement a graph using array and linked list, right? And we can have a coordinate set of coordinates, right? Or we have the edges, right? So like this is the set of edges, right? And we can, this is use the array list to create a neighbors list, right? So array list to create just, this is just the markup index, right, of all the neighbors. Or we can just make a mark to show this is adjacent, right, at each point. Use the two-dimensional arrays. Or we can do the sets, right, set of edges with a set of index. So we start to model this, right? We said first we need to create an interface graph. That's going to list all the methods that necessary for this, right? And then we're gonna have, we know that graph has wedges and unwedges, right? Graph. So we're gonna have two classes, right? Right, wedges means we're gonna have the numbers right between the edges, right? Can say distance between these two or prices to travel between these two. Unwedges is just have the path to connect it. So that's why it's a good idea just to create an abstract graph, right? And each abstract implement form the interface graph. Abstract method is the method. I mean, abstract class is the class that some method can be abstract. But interface is all the method are abstract. So that's the difference between abstract and interface, right? So meaning that when we create abstract graph, then some of the method we can implement, which is commonly used for both of them. Then we don't have to rewrite the code twice in these two graphs, right? Then we can just make the method that's commonly used for one unwedges and wedges. And then for some of the method that has to be depending on, right, wedges and unwedges, then we just make it as an abstract method. So that's how we model them, right? So let's look at so in interface we have get size, get vertices. So list return as, I mean that the vertices, we get the list of vertices back. Get vertex, pass in, we know what's the vertex. Get index, pass v vertex, we know index of that v. Get neighbors, so list of the neighbors returning back. So get degrees, so returns a degree for a specified vertex index. Print edges, so we can print all the neighbors, right? Clear, we can clear the graphs. It's just pretty much just empty the graph, right? Add vertex, we can start to add a new vertex. We do add edges. And this is depth first search and breadth first search, right? So these are something that we want to look at, right? So depth first search is just how we travel through the graph in the depth format. Go deeper, deeper, deeper until we visit all the vertices, right? And breadth first search, we just do same travels through the graph in like spanning, right? Breadthing, right? Spanning format, right? To all the neighbors first, visit all the neighbors, and then from each neighbors, visit all the neighbors of the neighbors, right? So that is how we expanding it out. Now these are the methods that we want to create for the graphs, and then we start to do abstract graph, implement that, right? So we have the vertices, neighbors. This is for neighbor for each vertex in the graph. So we add a couple more attributes, and these are protected, right, type. Constructors. So we have 4, right, overloaded, 5 overloaded constructors that you can have the default. You can create your vertices from an array that we pass in, or from the list, right? And edges from the two-dimensional arrays, or from the list edges. Like I said, we have many ways to create it. That's why we have different overloaded here, right? So we can also create the graph from passing in, right, the two-dimensional arrays, edges, and the number of vertices. Or we can just pass the list of edges and the number of vertices. It depends on how you construct the graph earlier, right? And add edge. We can add more edge here. Now for wedges, we just extend from abstract class and wedges first, right? So just call the constructors with the same 5 constructors overloaded. So let's look at the code here. So this is a test code. So we start to have an array. So we're going to construct a graph from the first type of constructor with an array of vertices and array two-dimensional array of edges. So these are edges and this is vertices, pyramids are the cities. We just pass into the unwedges graph. Now when we call get size, it's just return the size. Get vertex 1 just need to return the San Francisco if it's right correctly. Get index Miami, so it should return the correct index, right, of the location of Miami is. The edge for graph 1, it should return all the edges, right, which is showing here, right? So now let's look at how to implement this. So we just see a UML diagram or operations. So this is graph interface, and this is the abstract graph where we start to implement the constructor here, right? So constructor of abstract graph that we can say we're going to pass into array set of vertices and edges in. So when we start to construct them, we have to iterate through the list of the vertices and add vertex, call the method add vertex, right? Because graph has the method add vertex, so we have to look at how add vertex works. So it's going to add all the vertices. And also for the edges, we just call the method create adjacent list, which you pass in the two-dimensional arrays of edges and get the length in, right? So let's take a look at create adjacency list. So it's pretty much just so this one is only pass in what the edges and the number of vertices, right? So we're going to iterate from the I equal to 0 to the edges length.